Welcome to Space News Live this week. This is a live show I do every week at the same time, and I cover the videos I've done this week. I go over them, I recap them, I bring up comments people have left about the videos, answer chat messages, and so I normally do two dedicated videos a week, either on a topic or a company. And then I usually finish off with a space news roundup video. So that's 3 videos to go over. I'll cover other space news that I've not covered this week for whatever reason. And then usually what's coming up, what ideas I think I'm going to do for next week or further in the future. So that's the plan. So please join every week at the same time, and we'll get going with the first video this week, which was, if I bring it up, it's Lunar Cargo Non-Propulsive Lunar Landing Concepts. So I saw a video from the company. It's a Greek company founded in 2021, and they had some non-propulsive ways of landing on the moon. So I have covered one non-propulsive way of getting payload off the moon. That was a linear accelerator, which was in the Lockheed Martin video. So that's a fairly well-known way of getting, launching stuff. It's basically like a big electromagnetic gun. And it works quite well on the moon. There's no atmosphere, low gravity, so you can shoot stuff into orbit. So this is different concept. It's how to get things on the moon's surface without using a rocket, without using engines. So the company has two concepts, and these are just concepts, but the idea is it gets people thinking about alternative methods of getting stuff to the moon. The problem with propulsive landing is that I can put myself full screen at the moment. The problem with propulsive landing is it costs $1 billion for 1 ton to the moon's surface. So that's way, way too expensive by many orders of magnitude. So I'm sure there'll be improvements over time, but it's still going to be very, very expensive. And I say in the video, even with SpaceX's Starship, it's probably going to cost hundreds of millions of dollars for 1 ton of payload, even with Starship. So it's worth thinking about alternative ways of getting stuff to the moon, and these may appear to be way off concepts or like ridiculous concepts, but it's worth just having that debate. So I have a graphic here. There it is. So these are the methods, and basically to describe the methods, I'm not actually I'm not actually in space right now, and although it does look like it, I'm just actually sat down in the chair, but it does look a bit like I am on the moon, but I'm not actually. So thank you for that comment. So these are the methods. Mesodonus, which is a net and a catcher, and if you've seen the video, it's basically they have this net, and the payload comes in from space, and it basically hits the net, and then there's these tethers which slow down the payload over a 10-kilometer deceleration zone, and then there's a trampoline. There's a trampoline system at the other end that just catches the payload. It's wacky for sure, but that's the first concept. And the second concept is a giant wheel, a Plonus, which is exactly what it sounds like. It's a giant wheel. The payload's in the hub in the center. Then you have tethers to the outer rim, and it's tensioned by it's spinning at a particular number of revolutions, 8.6 revolutions per second, and that tensions the whole system, and it can basically land on the moon and the roll friction will gradually slow it down to a stop. So those are the two systems, which are pretty wild for sure. They're definitely wild, but it's a good idea to think about alternative ways of landing on the moon. And then I put in the third possible concept, which is a lunar space elevator. And it has some advantages and disadvantages. One thing I mentioned in the video is the problem with ejector and debris. When you land using chemical rockets, they kick off a lot of dirt and rocks and debris and moon dust. And depending on the size of the rocket engine, those rocks can be accelerated to enormous speeds. In fact, so fast they can actually go into orbit and actually escape the moon's gravity entirely. So the rock and debris could end up heading towards Earth. So propulsive landing, you can kick up a debris that can speed off at 4.3 kilometers per second. Now, the escape velocity for the moon is about 2.3, I think, or 2.6. It's something like that anyway. So that's more than enough energy. Oh, so it's 2.4. It's right up there. So that's more than enough energy to send stuff into space and escape the moon entirely. And who knows, maybe head towards Earth. So the Mace Adonis, the Netcatcher, doesn't produce any ejector. The giant wheel produces ejector 1.6. That's less than escape velocity. And the space elevator is also no ejector. So space elevator is just a giant cable. So you have your central station in space at the balance point. You have a counterweight on the underside, and then you have a cable that goes all the way down to the moon, and it actually is anchored. It's anchored on the moon. So the cable has to be very long. I mean, something like, I think it's going to be like 60,000 kilometers of cable, and it has to be defect free. But the advantage of the moon is that there are actually materials that you can use for the moon. For the Earth, it's just science fiction because there's no material strong enough to support a space elevator for the Earth. But for the moon, we have some possibilities, and here are some of the materials. I'll just hide myself for the moment here. So these materials, in theory, could support a moon space elevator. Xylon is probably the top candidate. It's durable, it's available. The only issue is not untested for space exposure, because on the moon, there's no, you're not protected by the moon's magnetic field. There isn't one. So basically it gets bombarded by solar radiation, solar flares, cosmic background radiation. So the materials are untested whether they can withstand that without degrading. I don't know. But other than that, Xylon works. It's tensile strength is 5.8 gigapascals. Space elevator needs something between 5 and 10. It does depend on the payload. So for small payloads, I've seen it could be just 3 to 10 gigapascals. So if you're just using it for, like, say 100 kilos, you could probably use one of the materials at the bottom of the list. The heavier the payload, you've talked about tons of equipment you want to use space elevator for, you're going to need something like probably Xylon or maybe M5 fiber, both of which are over 5 gigapascals. Kevlar, that's used in bulletproof vests, is also a possibility. It's feasible for lower amounts that you want to send to the moon. And then you've got this one here I've never heard of, but it's marginal strength. So there are some materials right now that you could build a moon space elevator from. The only issue is you need it to be defect free, and it has to be something like 60,000 kilos. And also anchoring the base on the moon is also problematic, because the moon dust is loose, so you'd have to excavate under the ground. You'd have to have some kind of anchor system. So you need quite a bit of lunar engineering for the base, and you need to put the station, and you need the counterweight, and you need 60,000 kilos of cable. But I threw it in there as a non-propulsive way of landing on the moon, and who knows, maybe there's much better ways of doing it that I don't really know about. So anyway, so we had a few comments on that. So bring up the comments. So I'll put myself in the corner. Okay, so Wayne said, Wayne's World of SciTech said, lander SMR, which I think means small modular reactor, so a nuclear reactor, with diode lasers first and fuse a landing platform. It might be possible to fuse a deep enough pad to hold a lander. I haven't got the numbers, but Rolls-Royce has a 25-year zero maintenance reactor. Yeah, there are small modular reactors built all the time. Nuclear submarines use nuclear engines. So like the US has them, China has them, the UK has them. These are small modular reactors, and companies know how to build them. So small modular reactors on the moon makes a lot of sense for many, many reasons. And Lockheed Martin are working on them. I've done a video on Antares, who are doing nuclear reactors for the moon. So yeah, I think any future moon base will have modular reactors. This is in particularly for the anchor for the space elevator. Yeah, so that's Wayne's comment. Hello from AR West, Massachusetts here. Thank you for joining. Yeah, we're talking about the first video, which is the Lunar Cargo Company, which came up with some non-propulsive ways of landing on the moon. So the comments are, we've had Wayne's comment. Wingsley says, one compelling technique that isn't discussed enough when it comes to launches and landings to and from a planetary body, skyhooks and rotovators. The link to one of Isaac Asimov's videos is 8 years old, but it gives a fairly good idea of what the concept involves. If we as a civilization ever get really serious about doing things on the moon, Mars, and even expanding launches and landings on Earth, we will have to look at skyhooks and rotovators. Isaac Arthur is a physicist and futurist based in Northeast Ohio. He is also president of the National Space Society. Yeah, I'm familiar with that guy, I believe. Isaac Asimov? No, Isaac Arthur. Anyway, I've vaguely heard of skyhooks, but I'd have to research that a lot more. Yeah, I mean, we need more concepts on how to land and take off in a non-propulsive way. I've done guns for Earth. I did a long shot. There's a video on long shot, which is basically a giant cannon, and you can use it to shoot things into space. You need the speed you need to produce is just enormous, but they're working on it. So space guns is also a concept. We have another comment here from Dr. Machine Work 1. A 50-kilometer cable would work for lowering objects to the moon's surface. Lowest lunar orbit is 30 to 50 kilometers. Yeah, so the way the space station works, the space elevator works, is you have a central hub, which is a balance point. So L1, the Moon-Earth L1 Lagrange point. These are just natural balance points, and there's 5 of them for the Moon-Earth system. So if you put something like a station at a balance point, station keeping is a lot simpler because it will naturally just stay there. And then you lower a cable from the central station all the way to the moon's surface, and then you anchor it. And then you put a counterweight on the other side. Or you could just have a cable stretching out that balances the cable, so like it's balanced on both sides. Or a counterweight. There's a few different design concepts for that. But basically, the balance point is 60,000 kilometers away. How would they lower the cable? How would they get the cable to lower? The cable would be orbiting with the spacecraft, because you start from the L1 point. Moon Earth L1 point is where you build your station, and that's where you start on unreeling the cable from all the way down to the surface. While at the other side you have a counterweight. That's how it works. In theory, at least. We've never done a space elevator, so who knows? Let's have a look at some of the comments, because that's all I have to say on space elevators and non-propulsive landing on the moon. So we have a comment here from Lincoln Polk, who has talked about CME, which is coronal mass ejection with southern polarity more dangerous. So yeah, I'm not an expert on solar dynamics, but coronal mass ejections are definitely something to worry about if you're on the moon or anywhere where you're not protected by a magnetic field. Even at the space station, you've got some protection because you have the Earth's magnetic field, even if you're 400 kilometers above the surface. But on the moon, you have no protection at all. So yeah, you need a habitat that can protect against solar radiation, or you could be in a lava tunnel, which I've discussed. There's a video on lava tunnels, or regolith around your habitat. But definitely solar radiation is a big problem. You've got to be careful about that. Yeah, and he also says he doesn't understand the physics on southern polarity. One thing, I don't understand the physics about solar radiation either. So you're not the only one. And in terms, what's Dirk? Dirk is saying, I'm not convinced about SMRs, that's small modular reactors on Earth. Too many providers to get economy of scale, but Moon, Mars, etc. It certainly makes sense. It certainly does. I don't see how you have any kind of base that's of any size, maybe a small, very small one. But once you start putting habitats together and so on, I think you're going to just have to have what they call surface deployed nuclear fission reactors. Lockheed Martin's working on them, Antares is working on them, NASA's interested in them. So I think that's just the way to go, especially when you start doing ISRU, that's in situ resource utilization. I think the amount of power you need, you're just going to have nuclear reactors because you've got all the lighting, you've got life support, you've got heating and so on and cooling. Then you start doing the excavation and processing. I think you just have to use nuclear reactors. And when you get to Mars, then you've got to deal with all the dust storms and so on. So solar is, I think, potentially you've got that other problem with dust storms. So I think nuclear reactor is definitely the way to go when it comes to powering bases off world. That's my point of view. And Dirk is also saying here, on the pole, a rotating shield, maybe. Yeah, I don't know. Maybe that's something I can do in a video, but yeah, I don't really know about that. I have seen some concepts of personal magnetic shields. You can do those kind of things, but yeah, that's not something I have a lot of knowledge about at the moment. So let's go to the next video, which is this one here. So Blue Origin Mark 1, Mark 2 lunar landers. So this is a two-parter because I want to cover the Cislunar Transporter, which I deliberately didn't really talk about much in this video, and that's on purpose because I'm going to do it next week. That's one of the videos I'm definitely doing next week because the Cislunar Transporter has implications beyond just going to the moon, and it could be very beneficial for space startups. But anyway, that's next week. This week I covered the Mark 1 and the Mark 2 lunar landers from Blue Origin. So Blue Origin, along with SpaceX, has a contract for HLS landers. That's Human Landing System. In other words, they will be landing astronauts on the moon under NASA's Artemis program. And you can see the lander on the right. This is the HLS system. So you can see there's astronauts around, and there's like the bottom area is where the astronauts. That's where they stay when they're traveling to the moon, and it can house 4 astronauts, 4 crew. The Mark 1 is just a robotic lander, just like from Intuitive Machines or from Firefly or iSpace, except it's quite large. It can land 3 tons. Actually, we have this graphic here. So the graphic is Apollo lander from the 1970s. So Neil Armstrong and so on came down in this. Buzz Aldrin. And so we had quite a few lunar landing missions in the 70s, and then they just stopped because they were very expensive. So now we're going back to the moon sustainably, and Blue Origin's lunar landers are the Blue Moon Mark 1, and this is the robotic lander. and the Blue Moon Mark II, which is for humans, crewed lander. So as you can see, it's 8 meters tall, and the human one is 15 meters. So the Blue Moon Mark I I've got a graphic here as well. It can land 3 metric tons, which is 6,600 pounds, onto the moon's surface. It's a single launch from a New Glenn rocket. That's Blue Origin's heavy lift vehicle called New Glenn, which has launched already once. And it uses one BE7 engine, which is LOX liquid hydrogen. And there are 2 of these systems being produced right now, Mark 101 and 102, which are both being built. And this is on purpose in case there's issues with the very first landing. The second one will be ready in 6 to 8 months later. So they want to be hardware rich. So that's great. They've got a CLPS payload delivery. That's Commercial Lunar Payload Services System. That's a kind of like private commercial lunar landings that NASA uses. That's the same for IM-1, IM-2, Firefly, Blue Ghost, and now Blue Moon. Hello, Wayne. YT didn't warn me. Sorry about that. That's, I don't know why. Anyway, I always do space news at the same time every week. Pretty consistent. And AR West is saying, Mark II looks good. Hope everything coming along smoothly. So I think there's going to be an update in a couple of months about Mark II. It was hinted at. In this video, there's the link to the presentation by VP of Blue Origin. So I think he's hinting about a presentation on the Mark II later this year. And I do mention maybe they'll show some hardware. I'm not sure about that. But there's definitely more news about Mark II coming along. You talk mostly about Mark I, because that should be launching by the end of this year, which surprised me. But I mean, the hardware is being built right now. In fact, I think the very first version, he said it will leave the factory in Florida in 6 weeks. Then it'll do some testing, and then it's ready to be encapsulated on New Glenn and launch by the end of 2025. So if that happens, that's going to be amazing. And Wayne's saying that, at YT, YouTube's overloaded today. I haven't had any notifications, missed 2 lives. Well, every week at this time, I'm pretty consistent on that. Okay, so that's the Mark I, 3 tons to the moon's surface. This will be the largest lunar lander landed on the moon so far. This is what they're saying. So normally lunar landers will land a couple of 100 kilos. This is 3 tons, which is a huge amount. So that's very interesting. And then we have the even more interesting one, which is the Mark II. This will land 4 crew on the surface of Mars. I think the first mission is 6.5 days near the South Pole. And this lunar lander is reusable though. So first of all, it goes to NRHO, which is Dirk saying how they get up to the launcher in Mark II. So this launcher here is not the first concept for landing on the moon. Their first concept was rejected by NASA, SpaceX 1, and there was a legal battle, and NASA decided, okay, we'll have two systems. So NASA won with their second system, which is this one. And unlike the first one, which had a very, very long ladder, it was like 50 meters tall, and it wasn't safe. It was just very dangerous. You notice with this lander, the crew are right at the bottom there. This is the ladder here to get to the surface. So this is a way better concept, a way better design. And this is much easier to get to the surface from here. And so I think it's some kind of donut shape with the engines going through here, and you've got the tanks up here and so on. So basically, the concept of our operations is more complicated. You've got the cislunar transporter that carries the liquid hydrogen, the oxygen. It goes to NRHO, that's near rectilinear halo object. then the Mark II launches. It travels to NRHO pretty empty, and then gets refueled. Then it docks with the Gateway or with Orion. The crew go down to the surface, do the lunar mission. Then it takes off, because this can actually take off as well. Then it docks in NRHO with Orion or whatever, and then it goes back to the to Earth. But the lander can just loiter, and if it's refilled, it can go back to the moon again. Then it can take off again, get refilled, and it can keep doing missions. That's the concept. And because it uses hydrogen oxygen, which you can make on the moon, it's potentially a reusable system. So that's very interesting. And the Cislunar Transporter, which is here, which I didn't talk about on the video, I'm going to talk about it next week. That also is very interesting for space startups, potentially, because they can sell to Blue Origin. But more about that next week. I don't really want to mention about that this week. But anyway, let's see if we catch up with the comments here. But the lower part is more the lander. Still unclear how they get up to the upper lander part. So I think this is just where the crew is, and these are tanks. So yeah, I think it's I think the whole thing launches again. Yeah, I'm not sure about that. You're making me think about that now. But anyway, here's a graphic I did on the system, just like, yeah. So these are Mark 1, Mark 2, 3 tons to the lunar surface. Mark 2 is 20 tons reusable and 30 tons expendable. Mark 1 is not refuelable. Mark 2 is refuelable in near halo rectilinear orbit. Mark 1 doesn't support humans. Mark 2 does. Yeah, this is the thing I'm gonna talk about. Is a bit of a shame that they designed it for Lunar Gateway, which is all but cancelled. But yeah, that's the thing, because they do mention in the concept of operations near halo rectilinear orbit, and if you don't have a gateway, then I don't know why they're going to that orbit, other than they've been contracted to go to it. So I don't know what's going to happen. I know Artemis 2, Artemis 3 are pretty secure, I think. So going back to the moon for the first human landing since the 1970s will be with Orion. But after that, I think SLS is getting scrapped, and Orion and Gateway. So I don't know whether NHRO is still happening. Yeah, so that's all a bit up in the air, to be honest. Yeah, they flipped the original design upside down. I mean, if you look at it, the first design, the crew compartment was way up here. It was like 50 meters, and you had this very long ladder. Oh, you probably can't see the mouse. So basically, it was at the top of the lander, and they had a very long ladder. Now they flipped it and put the crew right at the bottom, and it's very easy to get to the surface. This is a way better design than the first concept. So it's good that they lost the first bid, because the second bid is much better, and I do like the Cislunar Transporter as well. So yeah, I'm much happy with this new design from Blue Origin, and the liquid hydrogen and oxygen propellant system is also good. They also have a fuel system, a fuel cell battery backup system. Well, not batteries, it's fuel cell, but that uses hydrogen and oxygen as well. So it's all hydrogen and oxygen, which is good for companies that produce hydrogen and oxygen on the moon. So comments. Let's see, have I missed? So let's go over the comments people left on the video. Vic Oliver says, Bezos plans are currently short on a way of getting bulk material off the surface of the moon. Hydrogen is harder to extract than you think, even if they can find it, so it's only going to be used for moving people and lowering payloads to the moon. He's smart enough to know this, and I'm dearly love to know what plans he's got. So, like free hydrogen you cannot find on the moon, on not much. You get some from the solar wind, but the way you get hydrogen is I put myself in the corner. the way you get hydrogen is from lunar water ice, which there are billions of tons of lunar water ice suspected to be in the permanently shadowed regions, the craters, especially around the South Pole, Shackleton crater, and places like that. At the bottom of the crater, it's extremely cold, and there's never any sunlight. So any water vapor that goes into the crater is trapped there forever and can never escape. So if you process water, you can electrolyze it into hydrogen and oxygen, liquefy it, and store it. And there's your liquid hydrogen and liquid oxygen. And the space startups, that's their business plan. Their entire business plan is extracting water ice on the moon to produce liquid hydrogen and liquid oxygen and then sell it. And Blue Origin would be the perfect customer. Their entire system works on liquid hydrogen and liquid oxygen. And even SpaceX with Starship, 80% of the mass of propellant is liquid hydrogen. I mean, each Starship can store 1,000 tons of liquid hydrogen. So that's the business plan. Water ice, electrolyze, store. So the second comment is from Wingsley. So this is an edited comment because it was quite long, so I just cut out a few paragraphs. But he's saying a few questions, and maybe there are answers, and maybe there aren't any answers yet. This Blue Origin project, are they still talking about spacecraft that rendezvous in near rectilinear halo orbit? Yes, they are. Around the LM1 Lagrange point between Earth and the Moon. If Gateway Space Station gets axed, there won't be any use for rendezvous in NRHO. So where do they do the rendezvous? Low lunar orbit? Well, this is the question everyone's asking. I do mention in the video that SLS, Gateway, and Orion are probably going to get cancelled, but the concept of operations from Blue Origin is rendezvous in NRHO. That's what they're saying. They're still saying that as of now. So I don't know what's going to change. Yeah, I don't know. And he then goes on to say, and what about this new Blue Origin transporter spacecraft? That's the Cislunar transporter. Does it have a name? I call it Cislunar transporter. I don't know if there's another name. A specific stated purpose. Well, it's basically for refueling the lunar landers, Blue Origin lunar landers, but it could refuel any lander or upper stage, right? I mean, if it's storing liquid hydrogen, liquid oxygen, I'm sure you can approach Blue Origin and ask for, like, can we buy some of that liquid hydrogen and oxygen? I'm sure they're happy to sell it to you. So anyway, it's a gas station in space. Does it just haul cargo? Can it haul astronauts? So in the presentation, he mentions briefly that you can send it from Earth once it's refueled to NRHO, to the moon, with all propellant. Or it could be half propellant, half mass, or maybe just half propellant, half payload, or maybe just all payload without propellant. So it can be whatever you want it to be in terms of how much propellant. I mean, if you could refill it from the moon, you could send it without any fuel, right? But at the moment, it's going to be some fuel, but maybe some payload. Can it haul astronauts? No, I don't think so. If so, no. So it doesn't do astronauts. That's just the Mark II lunar lander. Zero Space Life Inflatable Habitat Module. Yeah, I'm going to cover the Cislunar transporter next week, so maybe I can answer some of these questions. Yeah, I really don't know that much about it. They've been very quiet about the Cislunar transporter. And he then goes on to say, in September 2016, yeah, AOS is saying good riddance, Space Launch System, and Orion. Okay, so he goes on to say, in September 2016, NASA personnel from the Amos and Kennedy Centers produced an internal study document under the title Kickstarting a New Era of Lunar Industrialization via Campaigns of Lunar COTS mission. That's commercial off-the-shelf missions. They examined how to get beyond the SLS issue, and the solution was a combination of commercial launches to low Earth orbit combined with robotic cislunar reusable ferry tug tanker. Yeah, this could deliver astronauts and cargo from Earth orbit to lunar orbit. At about the same time, ULA posted promotional video with essentially the same concept called ULA Innovation 6 Lunar 1000, proposing an advanced Centaur derivative called ACES, or Centaur Heavy, to serve as whatever. Yeah, ACES has been cancelled. I think it was cancelled in 2020. But some of the ideas ended up in the Vulcan Center upper stage, I believe. So we'll see what happens with the ULA. They got plenty of money now from Kuiper launches and so on. So hopefully they can come up with, they can make their vehicle reusable and so on. So we'll see what happens with that. So if I bring myself up here, that's the Blue Moon Mark 1, Mark 2 lander. And next week I'm going to do Cislunar Transporter. I know there's quite a few questions on it, but yeah, I need to do research and do the video because I'm interested in. This is basically an orbiting gas station. That's what it is. It could be in Earth, it could be in low lunar orbit or NRHO, I don't know. But it's very interesting and has impact for space startups. So I'm just going to go through the chats to see. I think I've answered all the questions here from Dirk and so on, and Wayne. Have I seen yes? Mark 2 looks good. Hope everything comes along smoothly. Yeah, so far, as far as I'm aware, everything's on track. Mark 2's a couple of years behind Mark 1. Mark 1 should be launching at the end of 2025, and I expect Mark 2 maybe a few years later. It's obviously way more complicated. You've got life support, you've got all kinds of stuff, so it's more complicated, but we'll see. My understanding it's on track. Bit of a shame they did it for Lunar Gateway, which is all but cancelled by now. Yeah. Okay, I think we're up to date on comments. So then it's bring up this. Yeah, so I just got this video out last week. I got this video out yesterday, and yeah, that's not the right one. Here it is. So I covered InnoSpace, which I've done a dedicated video on InnoSpace. The South Korean rocket launcher. They've launched some suborbital rockets, but they're about to launch a orbital rocket called Hanbit Nano. Here it is on the left-hand side. It's launching from Brazil, the Alcantara Space Center. That space center is the closest space center to the equator. So it should be launching in July, but it's been pushed back to the second half. There's some technical problems. They found some issues in testing, so they're gonna work on those the fixes for that. So second half of 2025, we should see the first orbital launch from a South Korean rocket company launching from Brazil. So that's kind of cool. That was the first video. Do I have anything to show? Yeah, I have this. Yeah, this is them testing their TEL, the Transport Erector Launcher, which is their homemade erector system here. And that's been shipped to Brazil already, ready for the launch. So I believe the rocket and all the equipment is now in Brazil. So yeah, so as AOS says, good luck, Korea. Yep. So fingers crossed they have a successful launch later this year, and I'll keep track on that. The second segment was on Apex Space. They're building a bigger satellite bus. They have 3 satellite buses now: Ares, Nova, and Comet. This is Comet. So I can't remember the exact payload size. It's like 100 nod, 200 kilos, and then this one is 500 plus kilos. And it can provide 5 kilowatts of power on board for more powerful sensors, energy-hungry sensors. And then, of course, they mentioned Golden Dome as an interceptor platform because, of course, every single satellite company from now on will mention their platform's perfect for Golden Dome because there's so much money, hundreds of billions of dollars for Golden Dome. So, yeah, that's Apex Space. I've not done a dedicated video on them. I've done a dedicated video on K2 Space, which are building giant satellite buses suitable for launch on New Glenn and Starship. Those are huge. Yeah, that's Apex Space, and then I covered Sierra Space getting an award from NASA to investigate their inflatable habitat concept for use on the moon, perhaps as maybe as habitats, maybe as tunnels to connect habitat modules or other infrastructure on the moon. Basically, you can launch them flat packed, and then when they're on the moon, you just inflate them. This is what they look like. So basically, here's that's the rigid structure in the middle, the central bit, and then you have a textile that can be inflated, and you can even put in windows. See here, they've stitched in a window. So yeah, they've been testing this technology for several years now, and here's some more. I got some more photos. If I bring this one up here. Oh yeah, this is a video. This is a video. Put myself in the corner. Yeah, so this is you can see here at the bottom bit, here is the inflatable modules, and they get quite big. They can be, I think, a third of the size of International Space Station with just one of these modules, and that's cut out for a window. And so here you can see there's just inflating it here. So the internal volume, I think, is something like 300 square meters. And yeah, they're testing out. Yeah, so basically they've been in inflatable tests where they just put more and more air into it and see at what point it bursts. And that tells you how strong it is. Yeah, so yeah, this is the Life Habitat inflatable module, and NASA's investigating and studying whether it can be used on the moon to create large habitats pretty quickly. So this is a burst test. You'll see it in a minute. You'll see it burst. Yeah. So that's the three news segments I did this week. I just want to watch it burst. It's about to burst any moment. Come on. There you go. There you go. So yeah, I mean, it passed the test. It's strong enough to be used. They just yeah, they're constantly testing it. So anyway, that is the space news this week that I covered. I think I have okay. Let me just go through some of the comments then. So Steph McGrath is saying, do you have any thoughts on the progress of Vasimir? I've not heard about Vasimir for quite a few years. I know it has very high ISP, thousands of seconds. I don't know whether it's still funded, whether it's getting NASA grants. Yeah, I don't know any news about Vasimir. Yeah, I don't know. But thanks for the comment. And that it is still not physically possible. I don't know what that's relating to. Sorry about that. Okay. So yeah, other space news. Bring that up here. Yeah. So Una Stella, which I've never heard of, successfully launched its independently developed small launch vehicle Una Express 1 from its site in Gohung, South Korea. So this is another South Korean small rocket launch provider. This is suborbital, so it's not going to orbit or anything. But yeah, this is news to me. I've never heard of this company before. So maybe they have plans to go orbital. I don't know. And then Gilmour Space identified the cause of a payload fairing being ejected. A power surge was culprit, and it's being fixed. So there's no new launch date. They'll have to apply for a new launch license and so on. But it was identified as some kind of power surge, some kind of feedback thing. So they're gonna fix that, and they're gonna try to launch again. Yeah, so keep you up to date on when Gilmour Space is launching. Gilmour Space is an Australian space launch company, and they are launching from Australia. So they've been ready to launch for about 6 months now. In fact, they've been ready to launch for several years. It took them a long time to get a launch license. But anyway, that is the space news. And then the question is, what am I going to do next week? I know exactly what I'm doing next week. Tuesday, I'm going to do a video on iSpace, and the reason I'm doing Tuesday is because it's landing on the moon Thursday or Friday, depending where you are. It's going to be Thursday or Friday. But they launched in iSpace is Japanese company. They do lunar landers. They launched in January, and they've been taking a very slow, low energy journey to the moon. They've been into deep space, all the way past the moon, way out in deep space, and circling around coming back around the Earth, doing a slingshot, and then heading towards the moon orbit. They've been in the moon's orbit for about a couple of weeks now, and slowly circularizing, slowly getting closer and closer to the moon. And Thursday, they land on the moon, hopefully successfully. And this is a second mission. And the US office has got a partnership with Redwire, and they're building a larger lunar lander called Apex. But this is their small lander, and hopefully it lands successfully on Thursday. So that's my first video of the week. And the second video is Cislunar Transporter. As I mentioned, there's been quite a few questions on that. I don't have all the answers. I'm going to research it, and I'm going to do a video on Cislunar Transporter. And that's my coverage of Blue Origin. Then I've done the Mark 1, I've done the Mark 2, I'll do the Cislunar Transporter, and then that's Blue Origin covered. So those are the two videos next week. So that is everything, I believe. So thank you for joining. And I do this Space News Live every week. And see you next week.